Dear friends and colleagues, welcome back to the Mangano Digital Academy. In this short lecture, we will talk about the intraoral scanner, and in particular we talk about precision. It's quite important to remember how the workflows goes in digital dentistry, because we have a scan phase for the 3D data acquisition. We go from the real world to the virtual world, and we capture three-dimensional information of our patient, the tissue of our patient, by means of beam computed tomography, in order to capture the hard tissues, particularly bone, but also, of course, the teeth. Then we have intraoral scanner that are very powerful device used to capture the information of our patient, the dentate model of our patient, and also the soft tissues. We have face scanner, of course, to capture the face of our patient. And we have also other additional devices like the digital condylography, in order to have the function of the patient real time. Then when we have collected all this data, then we can import all this data and put together all this data inside computer-assisted design software. We have several kinds of computer-assisted design software, like in prosthodontics, for example, we can have computer-assisted design software for modeling, for example, crown, bridges, full arch restoration, everything that is useful in prosto. But we also have guided surgery software, for example, and software that can be used to plan, for example, surgeries. And so we have computer-assisted design surgical software, and as well we have also ortho software, 3D ortho software for the making the proper diagnosis, and also formulating and preparing and establish the final treatment plan of our patient. Then when we have modeled, for example, in the computer-assisted design software, our restoration, our prosthetic restoration, our bridges, our full arches, then we can make them. And we can shift once again from the virtual to the real world by means of and using very powerful devices and machines like milling units, 3D printers, and selective laser sintering, selective laser melting machine. Then we have our devices, and we can, our crowns, our bridges, our surgical guides, our ortho devices, we can use these devices clinically, we can apply them. So we have the last phase done, the clinical application. So we have 4 phases in digital dentistry: scan, plan, make, and done. And it's the essence of the workflow. These are the essentials of digital dentistry. Let's talk about intraoral scanner once again, and let's focus our attention on the precision. That is a concept that is very important, because in the previous lecture I have described and detailed the concept of trueness. Now we need to talk a little bit about precision, and precision is also very important. And when we talk about the full workflow, we refer to clinical precision. For example, in prosto, as in these very important books, the Bible of Italian prosthodontics, we see that the precision, with the term precision, we use this term precision in a very clinical way, in a clinical manner, and it means the marginal gap of restoration. So if the crown is satisfactory or not, if the bridge is satisfactory or not, if it closes or not. So if a marginal gap is comprised between 25-30 micron, it's very satisfactory. I mean, some authors also suggest that a gap of less than 100 micron can be considered clinically acceptable. But anyway, we need to consider that this term, this definition is very clinical, and depends by the 4 phases that I have mentioned you before: the scan phases, but also the plan phases, and how we manufacture, we make our restoration, for example, and how we cement our restoration. So the 4 phases determine this clinical precision at the end. So this clinical precision depends by these 4 steps. And when we talk about an intraoral scanner, it's totally different, because precision has a different term. It's more mathematical, and it refers only to the scanner and not to the full workflow. What is an intraoral scanner? As I told you before, it's a device, very powerful device, that emits a light source, usually a structural light grid. This grid impact on the teeth surface, and the scanner is capable to capture the modification this structural light grid undergo through power cameras, and then these cameras send all the information to the software. The software is the real brain of the machine, and the software elaborates a point cloud that are then interpolated in order to give a surface reconstruction made of triangles that we call mesh. So more or less it is how it works. From a point cloud we go to a mesh, and then we have our standard tessellation language file, the STL. This is how it works, and usually the mesh is composed by triangles. It's a set of triangles that form the external surface of the scanned object. As I told you, it's very important to consider that the mesh is only a 3D reconstruction, it's not the object itself, and it's an approximation of the object because it's made of triangles. So we can have also different resolutions with the different meshes depending by the number of points we pick up, we select, and the number of triangles generated by means of an interpolation. Anyway, when we talk about polygonal mesh, we are talking about the reconstruction of the surface of the scanned object, in this case the dentate model of our patient. But when we capture several scans of the same model, same patient with the same scanner, are the results comparable? This is the question. So are there any deviation between the different scans taken by the same operator on the same patient, on the same model, the same maxilla, for example? This is the precision. So when we refer to the precision of an intraoral scanner, we refer to the random error. So precision is, for the intraoral scanner, an estimate of the random error. And together with trueness, that is an estimate of the systematic error, precision and trueness, they create the final accuracy of the model. So trueness is very important, it's key, but also precision is very important. And we could refer to precision using the term standard deviation, because it's a quantitative expression of the precision. The standard deviation, the deviation among different models captured by the same scanner at different times on the same object. So this is the precision when we refer to an intraoral scanner. It's an estimate of the random error. And it's quite easy to establish the precision using a reverse engineering software in vivo and in vitro. We can do it in vitro using models. For example, we can use the same intraoral scanner, we can capture 10 scans of the same model, and then we can superimpose these scans each other in order to understand if there are deviations among this model, this virtual model. If there are deviations, then we have a random error, then we have a standard deviation, and then we have an error in precision. But we can do it also in vivo because we don't need any reference value, any true value in order to evaluate the precision. So technically precision can be also evaluated in vivo. We can take 10 scans of the same patient, if the patient is very patient, and we can superimpose them using a reverse engineering software, and then we can evaluate the results. If there are deviations among the different models, then we have a low precision. If the models are almost comparable, then we have a very high precision. And accuracy is the sum of trueness and precision. Trueness is probably more important because it is the ability of a measurement to match the actual value of the quantity being measured. But precision is also important because it's the ability of a measurement to be consistently repeated. So we can have technically, a scanner could be technically very true and with a low precision, or very precise with a very low trueness. But obviously what we want is we want to have highly accurate machine, highly accurate devices, highly accurate meshes. So we need high trueness and high precision in order to have a reliable machine for clinical use. And these are the general definition for precision and trueness. Precision is also defined as the closeness of agreement between measured quantity values obtained by replicate measurement on the same object under the same specific conditions. So it's the closeness of agreement and deviation between test results. We don't need any reference, as I told you in the previous lecture, in order to evaluate the precision. Instead, for trueness, we need a reference value. So it's also important to say that when we talk about precision, we better refer to the mesh itself and not to the intraoral scanner itself, even if the intraoral scanner is a factor, because there are scanners that are more precise than other scanners. But anyway, we should refer to the mesh because technically there can be confounding factors, other factors that can generate an error in precision. and they can give a higher standard deviation. And these factors are the operator. For example, the operator can be affected by fatigue, but the operator can be more or less experienced, and also the environment, and also the patient. So the scientific literature has reported differences in precision for different intraoral scanners, but we also need to consider the operator and the patient factor, and also the environment. So when we talk about precision, we should refer to the mesh itself and then to the scanner. But obviously there are a lot of studies, in vitro and also in vivo studies, on the precision. Usually the studies focus their attention on trueness and precision, so the accuracy. In 2019 I have published this study comparing 5 different intraoral scanners in different application, simulation of application, the single implant, the bridge, and the full arch. And I have tried to compare the different scanners in terms of trueness, but also in terms of precision. And basically we have published already several studies before on this topic, also in 2017 comparing 4 intraoral scanners with Marian Burgia, and in 2016 with Eitan Mijeriski. It's something that we have done from the very early, when the scanners, the latest scanners appeared on the market, in order to understand the evolution of the results with the different intraoral scanners. I have to say that in the last 2-3 years the performance improved dramatically, so we are talking about very powerful machine. At the beginning it was not so. These models were prepared by my friend dental technician Uli Oshild. 2 models simulating 3 different conditions, one partially dentulous model, one single implant, one bridge, supported by 2 implants, and the other model is a completely dentulous patient with 6 implants. We used the scan body from the Megagen company, and we tried to compare the trueness and the precision of these 5 devices, the CS3600, the Emerald, the WEO, and the Trios 3, and the Omnicam from Dentsply Sirona. And this was the trueness evaluation. As we can see, as I told you in the previous lecture, trueness is the ability to match the actual value of the object measured, so it's a very important parameter. And green in this case was good, less than 30 micron of deviation in the different situations, the single, the bridge, and the full arch. As we can see, the single is much more, it's easier to capture an accurate scan of a single implant compared to the bridge, and of course compared to the full arch it is much more difficult. This for the trueness, but if we watch the results were more or less so. The best results were obtained by the CS3600, then the Trios were also performed very well. But if you watch the precision, already in 2019 we see that most of the scanners, they were highly precise. The results were highly repeatable. I captured 10 different scans for each of the model, and then I superimposed each other, all these scans, to evaluate the precision and the deviations among these different intraoral scans. Among each single group, they were very little, particularly for CS3600, for Trios, and for Emerald. For Omnicam and for the dental wing scanner, we had much more deviation, particularly in the full arch application. That is the more difficult application, of course. But as we can see, for the single implant, almost all scanners reveal less than 30 micron deviation, so the application is absolutely reliable in terms of precision. We have a standard deviation that is very little, results are very repeatable, and they are basically not affected by the operator fatigue, because we captured a lot of scans and we superimposed a lot of scans using a reverse engineering software, exactly as I showed you before, using in this case a mesh-to-mesh technique. And here the precision, as we can see, we are far below the level of 30 micron for the best scanner, even in the full arch. So we mean that some scanners are more precise than other scanners. There are statistically significant differences among the different scanners, and some machines like the 3600 from Kestrel Dental and Trios, they revealed higher precision when compared to the other scanner. And precision is a key feature for an intraoral scanner, because it's not only about trueness, also repeatability of the results is key. because of course there are variables like the operator, the patient, the movement of the patient, the environment, the light condition, and all these variables can create a problem for us. But if we have a very reliable machine, a very reliable technology of acquisition, a very reliable mesh construction, repeatable in the results, then we are lucky because we don't have to face some problems, and we can reduce and have little or no deviation between the quantity measured. And this is precision basically. So a scanner is precise if the measurement made by the machine on the same object under the same condition can be consistently repeated. So there are little or no deviation between measured quantity values obtained by replicate measurement on the same object. So once again, precision for an intraoral scanner has a mathematical meaning, has nothing to do with the clinical precision that refers to the full workflow. Here we are talking about the random error of the scanner, so we need to refer to the mathematical error, to the standard deviation of the scanner itself, and most of all, the model, the mesh generated by the scanner. So this term, this mathematical term, has nothing to do with the clinical precision. Thank you very much for your kind attention, and if you need some, if you have some comments, if you need some clarification, or you have some question, please don't hesitate to write me. I'll be very happy to reply to you and to talk to you.